Good morning, good afternoon, everybody. Welcome to your Friday HSM Hangout. My name is Jordan Roberts. I'm very, very excited today because today we've got Wayne Griffinberg, Autodesk Application Engineer for the HSM product lines. You've probably seen him on Instagram. Pull out your phones, go follow Wayne Griffinberg on Instagram to see his adventures. We're going to be covering 3D toolpaths and specifically how to contain them today. And as always, guys, these are live. They're interactive. So give shout-outs to your own Instagram handles in our chat. If you have any questions, something that doesn't make any sense, let us know. We've got application engineers, in addition to Wayne, on the broadcast waiting to take those. So this is really meant to be an informative teaching session. In the spirit of November, we'd like to have a quick poll. We want to understand what kind of CNC machines everybody's running today. We've got a couple other questions. This helps us understand who our audience is. Week over week, we see a lot of familiar faces. We always like to understand which equipment they're running. Wayne, any thoughts, any predictions on the outcome?
I'm thinking it's going to be Haas. We see a lot of, our polls show a lot of Haas users out there, people with Haas machines.
Look at this, 40% of our crowd today is running Haas, and we got 65% in others. So for the others, feel free in the chat window to shout out what machines you're running. That also helps us understand a little bit more about your environment. A couple more questions here. I want to understand what CAM software everybody's using today. So just let us know. Hopefully we're going to see a lot of HSM customers. And if you're using Fusion, for those of you that don't know what that is, that's HSM technology in a cloud-based package. It's really the product innovation platform. It's a very holistic approach to manufacturing. We'll include that inside the Inventor HSM and HSM Works because the workflow is essentially the same. Great, here we go. Polls are closing. Share. Wayne, take a look at this. So 76% is using the platform today. So we're in good company here. And then for those of you that don't have a lot of experience, when something doesn't make sense, let us know, and we'll jump right on that. Let's see what else we got here. Oh, this is probably a good one for today. I want to understand what industries everybody is supporting. Obviously, we're going to be really focused on our 3D toolpathing and some of those strategies. So just always like to understand specifically what sort of shops we've got on the broadcast. Great, look at that. So for the other, quite a few others out there, so let us know what industries you're supporting. And for those of you that are in the mold shop, medical, and automotive, we do have some fun treats for you. And Wayne, I think that's all I've got for the questions right now. We've got a couple down the road, but why don't we kick it off and let's show everybody more about containing 3D toolpaths with HSM.
Sounds good, Jordan. Thanks. So today we're going to talk about 3D toolpaths. We're going to focus there. I'm showing them. I'm going to walk through in Inventor HSM. Now, the things we're going to talk about, we're going to give you some tips and some walkthrough on setting up your 3D toolpaths. These things are not only specific for Inventor HSM. It works the same way if you have HSM Works as well as Fusion. So by default, when we're working with our 3D toolpaths, the toolpath, it wants to cut, or at least cut out the entire model that we're working with that you have in your setup, according to that 3D strategy that you're working with. So for instance, I'm going to do a 3D parallel on this first part right here. I'm going to select, I work with a ball mill, bring that in and say OK. So what it wants to do, it's going to work on cutting. Let me get rid of this one real quick. It wants to cut the entire model. So what I'd like to do in this case is I want to contain that toolpath within that pocket region. And that's really what this webinar is about today, is looking at some techniques we can use that you can contain your toolpaths within certain regions of your part. Okay, and as I walk through, I'll give you some tips and tricks as we go through. And as we walk through, if you also have some questions, please feel free to ask as we go through here as well. So as I'm walking through, I'm going to make some duplicates of these toolpaths. So I'm going to hit Control-D to make a duplicate of that toolpath. And what I want to do is I'm going to go in and edit this, and I'm going to show you how to change the containment area. So if I go into my Geometry tab, I'm going to change this from Silhouette to Selection. I'm going to select the simple region right around the edge of where the pocket is. And it does a tangential box or a selection around that area, which is going to contain the toolpath in that pocket. Okay, one quick tip while we're here. If I go over to the Passes tab, I can also turn on Machine Steep Areas. This is going to add more density. It'll add more passes in those corners where the toolpath would be relatively out of that steep area range. We can also provide a minimum and maximum step down and step over. I'm going to say OK. So now we've contained that toolpath right inside that pocket area. And we also, if you can see, there's more density in those areas where it's steep on the walls. Okay, another way to contain it, let's say we want to contain it around this area outside of the pocket. I'm going to make another duplicate, Control D, right click, I'm going to edit that, and I'm going to go into my geometry selection. I'm just going to add this boundary on the outside of the part. I want to include it all the way to the end, so I'm going to include that boundary. So it's going to look at that area outside of the box that I chose for the pocket. It's going to stay in that area along the part. So I'm going to say OK. And now we've contained it to do that area on the outside of the part there. Now there's another way that we can contain it by using the heights. So I'm going to make another duplicate, Control D, right click, edit, and I'm going to control this by the heights. Now I'm going to contain it by height. So if I go into my heights tab, I can choose off the model, selection, and I can choose a place on the model where I want that top height to go. If I select it, there we go. And now I want to choose the bottom area to be a selection as well. So I'm going to change the area. I'm going to contain that toolpath within that area. And as you can see, it contains it right in that area. There's a few different ways that you are able to contain the toolpath within an area of your part. Sometimes we have a case like this. In this case, I'm going to rough out this part. I have it roughed out, and it's cutting out those wide pockets there and the areas along the edge of the part. Now, to get a little bit more rigidity, when I'm cutting this part in the toolpath, I'd like to add some more rigidity in those walls. So I want to cut out the pocket inside the part, but I don't want to cut out those big holes in the walls. So what I did is we created a simplified version or simplified configuration of the part and inserted it into this assembly. That's that clear version you see right there. I'd like to use that version as a model override inside the toolpath to be able to cut that. So if I take this adaptive, I'm going to do another duplicate of that adaptive. I'm going to edit it, and what I can do is if I go down into my geometry, if I turn on the model override, I can choose. Now in Inventor, it wants to look at certain surfaces, but if you double click, it includes the entire model that you select. We can also include the setup model. This is the model that we used when we did our initial setup, which is that model that has the holes in it. So I'm going to disclude that. I'm going to exclude it, if you will. Okay, oops, I hit the X. Let me double check again. I'm going to say OK. It calculates, and now I have that roughing strategy that stays within that pocket of the model I'm overriding. One of the cool things about this, if I go and take a look, and I'm going to simulate this, one of the cool things is if I do a stock simulation, and I'll simulate it to the end, you'll see it'll do that pocket inside. It avoided that area from my setup model, but if I take a look and I compare the model to what's left on stock, it keeps that original setup model to drive. That's what's driving my comparison. So it's still going to do to check and make sure I'm not going to gouge on my model, so it's still using that to drive the toolpath. Okay, I'm going to turn that off. Really, really effective, really good way to work on your stock, being able to do the override of the model. Another way we see this is sometimes we have a case like this. Sometimes we have a toolpath that we're working on. Okay, I don't have, yeah, here we go. Sometimes we have a toolpath. I'm going to make this the default. I'm going to hit Shift-D to make this become the default. Sometimes we have some holes that we want to drill in the part later, in this case. And we do a toolpath. I'm going to do an adaptive, or let's say I do a parallel toolpath on this part. I'm going to choose a ball mill. Choose this one. And in that toolpath, it drops down. It wants to plunge down into those holes. Now, one thing we can do, in this case, we created some surfaces, some patch surfaces in there to avoid it dropping down into those holes. And what we can do is I'm going to duplicate that toolpath. I'm going to right-click, and I'm going to go down to that same model override that we saw before. And I'm going to choose those surfaces. I'm going to select this surface, and this surface. Now, since I have include setup model, it's also going to include these surfaces as well. I'm going to say OK, and now my toolpath will be really nice, and it's going to go along with those surfaces that I initially selected in my selection model, as well as those patches on top. Now, let's say we want to avoid those holes altogether. So another way we can do this is we can use our touch surfaces. So if I go into Edit, go back down here, I'm going to turn off the model override. I'm going to go into touch surfaces. And I'm going to choose these as touch surfaces. Now it's going to avoid those touch surfaces. That's why I choose in here, avoid touch surfaces. It's going to avoid that area altogether, and our toolpath will go and avoid that area. It still calculates from our setup model, but here it's avoiding that area where we have those surfaces. Now let's say we wanted to just machine on those surfaces. Another way we can do it is I'm going to duplicate this same toolpath. I'm going to edit this, and down here we have touch surfaces. This is the inverse of what we did with the avoid surfaces. So if I turn this on, it's only going to machine in those areas where I want to have the touch surfaces. So I'm using that geometry and the model override in this case. I've also, in this case up here, I did the model override. Here we're using those avoid touch surfaces and using them to drive our toolpath. Okay, so far what we did is we've taken a look at parallel toolpaths, how we can use geometry. We can actually contain it within a region. We've used heights to contain it. We've used adaptive. We've used model override with a different model to be able to contain that toolpath to get the geometry we want, to get the cut we want. Here we've used that same containment using the model override as well as surfaces, touch surfaces and avoid surfaces, to be able to drive the toolpath. Now these were all requiring me to select some geometry, but they're good ways to contain your toolpaths. We do have a lot of ways that we can apply our toolpaths that we can have them applied to all the different parts. It doesn't matter which ones, they're going to automatically update. When you go and do, like let's say, a template or copy and paste, where you don't have to select any geometry, it'll automatically recognize that geometry. A couple toolpaths we have that'll recognize its own boundary is our horizontal. So I'm going to switch over to this horizontal pencil setup. I'm going to hit Shift D to make that the default. And I'm going to choose a horizontal toolpath. I'm going to select a tool that has a flat bottom. I'm going to say OK. It calculates off the model, and it finds all those places on the model that have a flat surface that we want to remove or that we want to clean up. So it automatically finds its own surface, its own containment. Another toolpath that we use like that is it's our pencil. So a pencil toolpath, I'm going to go in and select a 1/8 inch ball. I'll select this one. I'm going to say OK. It looks at the model and it finds all those places where it can do those internal corners, automatically finding its own containment. So I'm going to take a look at some other ways we can do those as well, some different containment. So in the shaft and holder down here, I'm going to look at this toolpath here. So what we have, let me expand this down, is we have an adaptive and a parallel that's machining the top face of this part. Now, if we look at it closer, I'm going to go in and simulate this. Let me go up and do simulation. This is, in some areas, the tool holder's hitting and gouging our part. So what do we do to avoid this? What do we do to remedy that? So one way we can do it is using our containment. We can take a look at this. I'm going to right-click and edit that toolpath. And in the Tool tab, we have Shaft and Holder. So these are different ways that we can avoid collision with the part. There's different strategies you can use. I'm going to choose Trimmed. So it's going to look at the shaft and holder as it's doing the toolpath, and it's going to trim the toolpath in those areas to avoid collision. So you see that toolpath is going to run. It's going to run up to the point where it can safely do it without gouging our part. Now what I'm going to do is I'm going to duplicate this. I'm going to go up to Control D. And one way I can do is I'm going to edit this. Turn off our shaft and holder. I'm going to choose a tool that has a longer reach. Okay, and in my geometry, I'm going to choose rest machining. So it's going to look at that area that we trimmed off, the area that we avoided with the tool hitting, and we're going to do that from the previous operation. So it's going to calculate the area that we didn't machine where we still have material left on stock. So that's one way we can work and contain the toolpath to avoid collisions, is setting up the rest machining as well as doing the tool and holder to contain the toolpath. Now earlier I talked about being able to copy and paste and having the toolpath automatically update on the model. We can also do this with a template. So when I look at the copied toolpath, again I'm going to hit Shift D to make that the default setup that I'm working with. So I'm going to select these, I'm going to hold Shift, select those toolpaths, Control C, and while I'm in my copied toolpaths, Control V, copy those toolpaths over to the new setup. All I have to do is generate, and it automatically finds those places where we're containing those toolpaths. I'll let it calculate a little bit. So we just simply copied and paste. We don't have to select any geometry, and we can use that containment to make sure that the tool's not going to hit right on that new part there. We could do the same thing here, and we could save these off. We could say store as template if we ever want to bring these toolpaths into another part file or another setup. So you could store them locally as a template and apply them onto another part. Another way that we can contain the toolpath is looking at the slope. So in this case, we're doing a contour operation. Now contour works really well when you're doing steep walls. When it has those areas where it gets really shallow on the top of the part, there are other strategies that would work a little bit better. So in this case, I want to use a contour. I want to contain it to only those areas where we have a slope, where the walls are more steep. So I'm going to add 60 degrees. So it's only going to look at those places on the model where the walls are between 60 and 90 degrees. I hit OK, it applies. And now we have that toolpath that's only going to cut in those areas on a contour between 60 and 90 degrees. Now here I can apply a scallop or a parallel on top, which will work much more smooth, a transition between the top and the bottom of the part in this case. Another way I just want to mention is working with the contour. There's another thing we can do. I just want to show you while we're here talking about it. If I'm going to go in and copy this, actually let's duplicate this toolpath. And I want to show you in the toolpath here, this is another tip. As we're working, I'm going to turn off the slope for now. But as I want to show you this. Right in the passes, just like we did with the parallel toolpath, we can also machine shallow areas. The parallel did those steep walls. Here we have the shallow areas where we can get a little bit more fine-tuned to be able to have it do those shallow areas. So I'm going to say OK. It'll calculate in the contour, and you can see where it gets more dense in those shallow areas to make sure we have a more uniform surface area or uniform surface when we're done machining it. Okay. So the last set I have right here is our contact point boundary we're going to take a look at. So I have a parallel toolpath. This is really helpful in the molding industry when you're setting up molds. This toolpath wants to arc over. It wants to roll around the corner on the top here. And when you have this as a mold, you don't want that rolling around because you're going to get material within that area. So we want that to be refined and stop right at the top of that mold cavity there. So I'm going to edit this toolpath. And one thing we can do is right in the geometry tab is turn on contact point boundary. So it's going to look at that top edge, look at where the tool is going to roll around that top edge, and we want to make sure on that top boundary it doesn't roll around. Say OK, recalculates, and now we can find, or shall I say, we contain that toolpath within that region and turned off the place where it's going to roll around that top edge. So we've looked at a lot of different ways we can contain the toolpaths. Okay, we select geometry. Model override is another way to work with it. Using model override where we can avoid holes using surfaces. Also touch surfaces we can work with to contain the toolpath within a surface region, and also to let you know you don't have to have surfaces drawn. You can select any region on the part and use that as a driven surface where you can contain your toolpath. So we're horizontal. These are toolpaths where they find their own containment, where it'll find all those flat areas where the tool can go most efficiently to remove that material. And pencil toolpath, again, finds its own containment area where it looks at those internal corners to apply. So in our shaft and holder, we're able to use tools like our model or our holder and shaft and holder, where we can trim. We have other ways pull away. We have other strategies where we can keep that tool or the tool holder from gouging our part. Another way to contain the tool path. We can even use rest machining to get those areas where we avoided a collision. Copying and pasting, showing you that a lot of these toolpaths that we work with where we have containment regions, you can copy and paste and they apply right to other parts. You can even do them as a template. Slope, controlling the slope. We can put in the wall, the straight walls if we want, and we can confine it to only look within those slopes of those walls so we can apply the toolpath most efficiently. Okay, and working with parallel, or in this case parallel, working with, we're able to do contact point boundary to keep that tool from rolling around edges where we don't want it to go outside of. So those are some ways to walk you through how to contain your toolpaths, to be able to work with them, and really applying your toolpaths in a really efficient way to keep it engaged where you want to on your model. So it looks like there's a couple of questions to walk through. Looks like it should be noted that if you use touch surfaces, it will offset the amount of the field. If you need it to touch the surfaces, the distance should be 0. Okay, that's good. Thanks, Neil. So that's a good point that he's bringing up. So if you're using those surfaces, you want to make sure that you're contained on top of that surface. Okay, got another question going there. Okay, it looks like Ben is asking. No worries, Neil. No worries. So Ben is asking a question, what's the difference between ramp and a contour? So a contour, what it does when you're working with a contour, it'll go around the model but stay at one level. It'll stay, in other words, it'll go around in your Z and then step down, come back into the part and go into the Z. Now, when you're working with a ramp is a constant engagement around the material. So when you work with a ramp toolpath, so if I look at a ramp at one here, and I'm going to look at this part, make sure I'm in this default. So if I would have did that, it would have been in the left default toolpath. So I want to make sure I go into slope. I'm going to hit Shift D. That makes it my default. So now when I add a toolpath, it's going to be in that default. It's going to look at that part. So I'm going to choose a ball nose and mill. So a ramp is going to try to keep it engaged as much as it can with the material. But again, it's a constant engagement, so it stays and it ramps its way from one starting point this way. It actually did on the outside, so I didn't contain it only to the top of the part. I would do that from the bottom. But it ramps in and it finds the place where it can keep that constant contact, but it's always moving in the Z. So it's going to work its way down like it's spiraling down in the Z. And that's one of the main differences. But you can contain it the same way. So if we're looking at containing that toolpath, we can use a slope as well. And I only wanted to look at those places between 60 and 90 degrees. Even in the ramp, it'll recalculate and only look at those places that make sense where it can ramp within those boundaries. I also want to set a boundary so it doesn't go down to the bottom of the part. So I can also do this. Using heights, I can say my bottom height, I don't want it to go below that face. So I use the bottom height to contain the toolpath so it doesn't go below that bottom face. So another way that you can apply the heights, or you can apply the avoidance, or different ways that you can apply containment to your toolpath. Looks like it says when I use the ramp, with the same settings, it generates 3 to 4 times more lines of code. Why is that? That's a good question, Ben. So as we look at the way, because we're getting also Z moves in there too. So as you're using a contour, it's only looking at your X and Y coming out, moving down in Z and X and Y. So when you're using the ramp, you're getting all three vertices. In other words, you're using the X, Y, and Z simultaneously. So as you walk down, you think you would have less code, but it all depends on the number of points, because now as it steps down, if you're doing linear, depends on how your tolerance set up, you would get a lot more code because it's constantly moving. You're constantly getting points in the X, Y, and Z. But that's the way I think of it. That's really my understanding of how it works. I could be wrong about why you're getting more code. There's a lot of variables in there, the way your tolerances are, if you have smoothing set up, really how you're looking at your machine interprets a lot of that motion, your post. So there's a lot of variables as to why you would get more code, but as far as the differences between the toolpaths, those are the things that I see. Okay, so it looks like we got a question. Can we show the model selection for the rough adaptive example in the model tree? The rough, okay, so the rough adaptive. Okay, are you looking at this one? You want to see how this looks in the model tree? So if I go into the model tree, so we have some containment. This is our model 3D for the Toolpaths. We just simply inserted a copy of this that has those features in the solid body. That's the simplified version. I think I'm looking at the right ones. So we just simply inserted another model that's simplified. So the version of that model, that solid body, doesn't have those cutout features in it. So we just inserted that in the same position as the version of the model with these cutouts. So there's a couple different ways you can work. If you're working in the assembly and you have your model, you can have versions. You can have multiple bodies, solid bodies. One can represent that simplified model, which we do this in SolidWorks with configurations. You can have one of those bodies in the solid model itself that represents the simplified version, and then another model that represents the version that has the features in it. And you could choose from those bodies while you're working. You can choose those bodies as you set up your toolpath. That gets a little bit out of the range of this webinar, but we do have some quick tips on showing you how to do that, how to set that up. All right, we can make a lot more quick tips in the future to walk through those specific questions. All right, so that's what the history looks like. A lot of these are copies placed in here to work with. Some of them are dumb solids, if you will, that were imported from SolidWorks. So go back to our CAM. Okay, so it looks like we're not having any more questions. This was going to be a little bit of a short one today. I just wanted to make sure we got some good information out to you regarding how we work with containing our geometry or containing our toolpaths within specific regions of our models. So hopefully that was helpful for you. Thanks. I appreciate it. And if there's any other questions, please feel free. We have some time here. We could jump in and answer some questions if you have them. You can always get in touch with the team. Thanks, guys. Yeah, I appreciate it.
Wayne, it looks like we might be able to give our audience some time back in their day. How about this? Just real quick, in a browser, pull up a couple of the resources we always like to make people aware of. If you don't know, we've got the Autodesk Knowledge Network, the CAM forum, and the education program. So the CAM forum, I'm sure that this audience is well aware. However, it's a great resource, and it's a place where you can contribute. You can show off your technical chops and what you know. You can also get your questions answered. And then we've got the idea station as well, which if you've got an idea as to where the product should go, what we should include in the development path, this is really kind of an incredible thing, because we want to hear from our end users as to what they need built into the product. You can upvote those suggestions, and the best ones we've already seen get integrated into the product pretty rapidly.
That's a really good point, Jordan, and it's a great place to go. We have them within our forums, a very active forum. We have a lot of our users in there, as well as developers are in there answering questions. We have power users. A lot of Autodesk Elite users are there to help you get some of those answers. You can also search our forums for places where you have questions, especially with 3D Toolpaths and ways to contain them. Search our forums. You'll find a lot of answers in there. As Jordan had mentioned, if there's places where you see um, maybe a function could be added, or a place where something doesn't seem to be working the way you expect, you can enter or add a post in here. And if other people feel the same way and they think that would be a great thing to add or a great thing to fix, they can vote for it. And the more votes we have, the more we're going to see those changes get into our developers, into their workflow. And the more votes that we have, they take them very seriously. They look at these requests that we have in here and quickly turn around and be able to get information back and be able to add those changes into our software. So we're constantly trying to make it better. Your help is definitely something that we pay very close attention to, is our user base, to make sure that we're hitting those points that most of our users want. So this is a great place to look, as Jordan had mentioned, on our forums again. If you're working with your post processors and you have specific questions on posts, you can look into our forums on the post. I'm going to go through our main site and our main forum, because this is sort of like a search. But here you can find more information on post processors. Again, it is a forum that is actively monitored, and we have a lot of users, power users in here who help you get started. Even editing your post processors, places where you can search to find for help on your posts. So it's a great forum to go to. Another great resource is our Autodesk Knowledge Network. And I'm pretty sure I have a link in here for our Knowledge Network. I thought I had a good link. That's
Yeah,
okay.
what's really cool about the Knowledge Network is this originally was intended as an internal resource for Autodesk employees, but now everyone has access to it.
So if I'm looking for HSM CAM and I want to go in here and I want to find out more about, let's say, 3D Toolpaths or just 3D, it'll look in CAM, and all those places where you can find more about 3D milling, some tutorials, some places where people have been contributing onto our site, a lot of videos, walkthrough videos. In fact, the one we just walked through today, and getting started, looking at some of those ways to contain your 3D Toolpaths. You can always do a search in our Autodesk Knowledge Network to find a lot of resources for training, as well as answering some of your questions.
And then the last piece was, see, well, we've got the Autodesk dictionary, but let's go to the education component of this. So I know Wayne's a huge supporter of education, really active at the Haas Techs. If you guys ever have an opportunity to attend one of those events, they're absolutely amazing. But here, you can just Google Autodesk Education, or you can go to autodesk.com/education, and you have access as a student or an educator to free Autodesk software. So a lot of universities out there are spending money on software, and Autodesk is giving access to technology. They're putting the access to this technology into the hands of the students of tomorrow and today, and the facilitators. So take advantage. You know, someone teaching a class, they don't leverage this program. Let's make sure that they start to.
This is a good example of all the different software that you can download for free in education and work with it. And we have all of our HSM choices in here that you can work with: Inventor, HSM, HSM Works.
Oh, and then here's one, go down to the NetFab one. Click on NetFab real quick, Wayne. This is a really neat new technology. I know additive manufacturing is hot right now. It's not necessarily a new technology. Additive has been around for quite some time. However, Autodesk made this acquisition. So if you can get this technology, it's an end-to-end 3D printing solution. You can also just go to netfab.com to learn more about it. But for any of you that want to branch out, diversify your business lines, and get into some additive stuff, I'd highly encourage you to take a look at netfab.com. And there's 3 different tiers as well. A lot of the same idea with the HSM product holds true where you can get in there and get access to great technology for really minimum investment.
Very awesome. So there's a lot of places where you can get into contact with us, with our team through our web portals and our websites and our community. Lots of training that you can find, education, downloads to work with. So we have a really active forum and a group to work with. So hopefully that was helpful for everyone, walking through some of those ways to contain your Toolpaths. We're going to have a few webinars coming up in the future. I think over the next couple of weeks, I know we have Thanksgiving coming up and we have Autodesk University. So we might not be so active with our webinars over the next few weeks, but coming up we have some great stuff. Some really good speakers, some awesome people who want to tell you about their experience working with HSM. And there'll be really good webinars we're going to have posted from our team for you to join.
So Wayne, you brought up a good point there. Autodesk University, for the crowd that maybe knows or doesn't know, this is a large customer event that Autodesk puts on, and it happens every year around this time in Las Vegas. And it's a great time. I've had the pleasure of attending the last 2 years in a row, but people like Wayne go and teach live classes, and there's a large trade show where you can learn more about new technologies that are changing the world. I highly encourage everyone to consider taking a look at attending Autodesk University at some point throughout their experience working with Autodesk. It's an amazing event.
Absolutely is. It's a great time. And there's a lot of information there, a lot of classes, ways that you can get more information and work with people directly, with a lot of the users as well as a lot of the teachers and AEs. And it's a great learning experience to go to AU.
And I think they even have certification programs on some of the Autodesk platforms. So if you're looking to advance your career and maybe get some certs, I mean, obviously you don't need to go to Vegas to do that. However, there's just so many different ways to look at justifying the time and the trip. And I just absolutely couldn't be a bigger fan, supporter of this initiative. So Wayne, what do you think? Let's give some people some time back in their day.
Absolutely. So it's
All
been a
right.
pleasure. I'm happy to share. If there's any more questions, please feel free to get in touch with the team, get in touch with Jordan, work through our hub team as well. And they get into questions back to us. Again, go into our forums. Please feel free to do a search, ask questions there. A great resource for you. So with that, hopefully this has been helpful. Thanks, Jordan, for hosting and having me today. And I'm looking
Hey,
forward
Wayne,
to the next ones.
it's a pleasure. And yeah, and just so everybody knows, we also have a Wednesday Kickstart that happens, so be on the lookout for that. That time is really focused around people that are new to machining, that are new to the platform. So if you've just downloaded it and you want to have another kind of one of these live Q&As, you can do that on Wednesdays. And then if you need to get in touch with us any other time, just send us an email. We'll get you on the calendar. And glad to work over your parts. So same place, same time on Fridays as well. And looking forward to hearing from Wayne and other special guests in the future. And thanks so much for your time, everyone. Have a great weekend.
Thanks, everyone. Have a great weekend. Bye now.